And now we move into probabilistic models. So we're moving away from deterministic to probabilistic, which means that demand and lead time are probably not going to be known or constant. So we also are interested in safety stock. So one way to handle when demand fluctuates is to hold on to stuff called safety stock. So it's inventory that you hold to cover any fluctuations in demand, especially during lead time. So the reorder point becomes what our basic reorder point was, little d times big L, plus whatever we decide to hold for safety stock to handle those fluctuations. And then our annual stockout cost can be calculated as the sum of the units short times the probability of that occurring times the stockout cost per unit times the number of orders per year. So let's look at an example of the safety stock. Our reorder point by default that we've used in the past is 50 units. I think we're doing eyeglass frames here. We normally order 6 times per year. The stockout cost is $40 per frame. Carrying cost is $5 per frame per year because they're relatively small, so it's not that big a deal. And then we have a probability distribution showing what demand looks like during lead time. Where did that come from? Hopefully it came from historical records. So what kind of distribution is it? If you said normal, you should fail the course. If instead you said it looks like a discrete distribution, because there's only 1, 2, 3, 4, 5 different possibilities that can occur during lead time. Either we have demand for 30 units, that happens 20% of the time. We have demand for 40 units, that happens 20% of the time. We have demand for 50 units, that happens 30% of the time. For 60 units, 20% of the time, and 70, 10% of the time. There's no 31, there's no 57, right? So there's only 5 possibilities, and those are the 5 probabilities associated with it. They add up to 1. So now we can do a calculation of when we stock out. Well, at the current reorder point of 50, then what happens is how would we ever stock out? Well, we could stock out 30% of the time, 20% being if demand for 60 shows up during lead time, and the remaining 10% is if 70 show up. How many short would we be for the 60 showing up? We'd be short 10. We'd be short 20 for the 70 showing up. Right? And then the other thing we want to look at is moving the reorder point up to 60, so holding a safety stock of 10 units. And then moving the reorder point up to 70, which would be holding a safety stock of 20 units. Right? Then we need to figure out how much we're going to short each time. So again, a nice tabular format. With a safety stock of 0, that's at our current reorder point of 50, we don't have any additional holding cost. Makes sense, we're not holding anything extra. Our stock out cost though is we stock out 10 when 60 shows up. That happens 20% of the time, times 40, times 6 times a year. Plus we stock out 20, 10% of the time. That's times 40 times 6, that's $960. So the total cost is $960. If we keep a safety stock of 10, then it costs us an additional $50 in holding cost, and we can only stock out one way, which is if 70 people show up, and that happens 10% of the time. So its stock out cost is $240, and so the total cost is $290. And then the safety stock of 20, then we have everything. We can meet demand no matter what during lead time based on our historical probability distribution. So we just have additional holding cost of $100. And then we see that the cheapest way is to go ahead and keep a safety stock of 20 frames. So our reorder point is actually 70. So whenever we get down to 70 in our stock closet, then we reorder. And it's going to cost us $100. That should kind of make sense. The stockout cost is $40 is quite high compared to the carrying or holding cost. So that makes sense that we'd probably go ahead and bump up the reorder point by quite a bit. Now, we can also use prescribed service levels to set safety stock when the cost of stockouts can't be determined. So there we knew how much it was going to cost to stock out. It was $40. Right? We knew how many times we were going to order per year. So here the reorder point is going to be demand during lead time plus Z times sigma sub DLT. Sounds almost like a sandwich. Z is the number of standard deviations. Sigma sub DL to T is the standard deviation of demand during lead time. So here we do have to know what the standard deviation of demand during lead time is going to be in order to use this particular model. Right? So what that's saying is, here's what our curve looks like, right? We got nice squiggly lines now because we're doing probabilistic. It fluctuates as we go down and up. We have a current reorder point there at 350 plus some safety stock, right, of 16.5. Safety stock is 16.5. Our lead time is down there where we receive the order. And we say the minimum demand during lead time is here. The maximum is all the way down here, right? So we get rid of stuff faster. The mean or average is there. And then we're hoping that there's a normal probability distribution between those during lead time. And the expected demand during lead time is at 350 units. Right? So we're trying to find a nice safety stock that will keep us from stocking out too much. And in order to do that, we often set service levels as a percentage usually. So the probability of no stockouts, that's our service level, is 95% of the time. So that means we want to move our safety stock all the way up to some point, right, so that there's only 5% of the time that we stock out of this particular item. So let's look at this example. So the average demand, I think this we're doing with resuscitation kits at a hospital. Average demand is 350 resuscitation kits during lead time. Standard deviation is 10 kits. There's a 5% stockout policy. I don't know if I'd want to go to that hospital. Maybe the doctors are really good, so they don't need resuscitation kits. Using Appendix I from the book. Is that I or 1? I'm not sure. Probably 1. For an area under the curve of 95%, Z is 1.65. It's really 1.645, but who's counting? So the safety stock is about 16.5 kits, and then our reorder point becomes the 350 plus the 16.5. If we bump it up to 367 kits, which really it probably does need to be a whole number, then we actually are doing better than a 95% service level slightly. And if we bump it down to 366, then we're doing slightly less.